Hi everyone. So today we're talking about the quadratic formula. And what the quadratic formula is used for is solving quadratic equations. And what I find a lot is that students kind of use the word solve as their go-to word in math. Any math problem I give you, you say, do I have to solve this? Do I have to solve that? Solving actually has a very specific meaning. When I say that I want you to solve something, that means I want you to find what the variable equals. So I want you to find what x is equal to. Okay, find a value of x that you could plug into the equation and have it come out to be true. So there's a lot of things you can do with equations besides solve them. Like what we've been doing so far, we've been converting things to vertex form, converting them to standard form. We've been finding out, different properties of the parabola. We can graph things. All of those things are separate from solving. Solving means I want to know what would x have to equal in order for this to work. Okay, so just so you can kind of clarify what this process is all about. The goal of this is so that you can say, if the equation equals this, then x would have to equal blank. So here's why we use this giant quadratic formula, which you'll see in just a second. You already know how to solve equations that have x in them. So if I gave you something like 3x plus 4 equals 10, you could solve that pretty easily. You could tell me what x would have to equal. X would have to equal 2 here. Okay? You also know how to solve equations with x squared. Like if I give you x squared minus 7 equals 42. You can add the 7 to the other side and then take a square root and find that x would have to equal, well, it would have to equal 7. I used a lot of 7s in that problem. So you can find what this x would have to equal. But what you've seen with these problems, the problems that are in standard form for quadratics, usually have an x and an x squared in them. So they might look like this. 3x squared plus 4x minus 2. Whoops. Minus 2 equals, 10, something like that. You don't have any methods yet that would help you solve an equation that has an x squared and an x in it at the same time. And that's what the quadratic formula is used for. It's a totally different method from everything you've ever learned about solving equations. So really with these two things, you use inverse operations. You would subtract 4 and divide by 3. You would add 7 and square root. Those are all inverse operations. This is a totally different ballgame, and it uses a totally different method. But the goal is still the same, is I want to know what could I plug in here and here that would make this expression come out to equal 10. Okay? So here's what the formula looks like. X equals negative b plus or minus b squared minus 4ac all over 2a. And those a's, b's, and c's come from standard form. So down here it says equations must be in standard form. Okay. And you're used to standard form looking like this. Y equals ax squared plus bx plus c. So that's standard form, and then of course the a, b, and c here are what all of these are in the formula, the a's, b's, and c's in the formula. To solve it, you can't have an x and a y in there, because remember that if it has an x and a y, there are lots and lots of different solutions, because every solution is just a pair. So instead of having a y here, we're going to have a 0 here. Okay, so before we start to solve, we have to be in standard form, and we have to set everything equal to 0. So this is what we want our equations to look like before we jump into the quadratic formula. If your equation doesn't look like this, you can't start this. Okay, you've got to have it look like this before you can start the formula. The thing I want to remind you of, and this is a little bit of an oversimplification, but all quadratic equations have 2 solutions. Like I said, that's a little bit of a lie to you. because remember when you take a square root of a negative, you get no solution. And then there's also a situation where you would only get one solution. But most of these are going to have two solutions. And the reason we end up with two solutions from this formula is this plus or minus right here. Okay? That's actually going to be two different calculations that you're going to do that's going to lead you to two different answers. So you'll see that when we start working the examples. Okay, so let's take this first one. So first of all, this is not in standard form set equal to 0. I've got 10x squared minus 13x, but then it equals 3. So to get this in a form that I can actually work with, I need to move the 3 over here and have nothing left on this other side. So I'm going to minus 3, and my equation now looks like this. 10x squared minus 13x minus 3 equals, now since I have nothing left there, it's going to equal 0, which is what we wanted it to equal. Then we're going to identify A, B, and C, and you already know how to do this. The A would be 10. The B would be negative 13. And the C would be negative 3. Okay, but again, can't do this until your equation looks correct. You can't do it with the 3 over here. Okay, and I'm just going to jot up here what we found a second ago just because it's on a different slide. So we found that A equals 10, B equals negative 13, and we found C was equal to negative 3. Okay, so let's plug that into the formula. Here this says negative B, which is very similar to when we were finding the vertex. Remember we had a negative B in there? Well, our B is already negative, so I'm going to plug in a positive 13 there. Okay, because negative makes a positive. Plus or minus square root of, very, very important here. When you are squaring a negative number, you have to put the number in parentheses in your calculator. If you don't, it's going to make you get the wrong answer every single time. You're going to hear me say that a cajillion times between now and the end of the year. In fact, if you walk out of my classroom remembering one thing and one thing only, I want you to remember that when you square a negative number, it has to be in parentheses. Okay? And in fact, again, I would probably just always put this number in parentheses, and that way you don't have to worry about it. So, again, I just plugged in my B value for B, and then it's minus 4 times A, which we found was 10, times C, which we found was negative 3, all over 2 times my A value, which is 10. Okay, now time to evaluate that. And to evaluate this, you've got to do it in steps. There's no good way to type this all into your calculator all in one shot. It's possible, okay, but even I usually mess it up because there's so many different parentheses that you have to put in. It's really better just to do it in steps. The first step I always do is just all of this stuff underneath the square root symbol. So I would do negative 13 squared minus 4 times 10 times negative 3. So I get x equals 13 plus or minus the square root of, let's see, that's going to be 169 plus 120, which is 289. Okay, so again, I just did negative 13 squared minus 4 times 10 times negative 3 all over, and this, I'll go ahead and do this too. So 2 times 10 is 20, so all over 20. Well, the square root of 289 is 17, and then I want to use the fact that this is a plus or a minus. As soon as I reach this point where there's nothing else I can do without dealing with the plus or minus, I have to split into two separate equations. And that should look familiar to you. We've done other stuff in this chapter where you have to do it in two separate equations. One of my equations is going to say 13 plus 17, which again, the 17 came from actually doing the square root of 289. Okay, square root of 289 is 17. So 13 plus 17 over 20, and 13 minus 17 over 20. Okay, I now have to solve, or I now have to evaluate each one of these separately. In your calculator, if you're going to type this in all in one shot, just like we had this problem when we were doing the vertex form before, you have to make sure you put this top part in parentheses, because you want your calculator to know that you want to add these numbers on top together before you divide by the 20. So 13 plus 17, I believe, is going to give me 30. So this is really 30 over 20, which is 1.5. And then 13 minus 17 is negative 4, and negative 4 over 20 is negative 0.2. Okay, negative 20%, I believe. Yeah, negative 0.2. That means these are my two solutions. So for my final answer, I would say x could equal 1.5, or x could equal negative 0.2. And so that means if I were to go back up to this original problem and plug in either 1.5 or negative 0.2, this would work out to where it equaled 3 at the end. Okay, I know that doesn't seem like a big deal now, but there's a lot of situations, a lot of real life applications where you would have to know how to do this. And we're going to talk a little bit more tomorrow about the graphs of these equations and why these numbers matter, what these numbers do for your equation. Okay? So let's try another one. This one is not in standard form. So I'm going to have to simplify this, which means I'm going to have to either FOIL or use the box method. And I know many of us are fans of that box, so, oh, I'm going to need it to be a lot bigger. Hold on. Maybe that'll work. So if I was going to multiply these together, let's see, I would have 3x and negative 6, and then negative 2x and positive 1. So 3x times negative 2x, that gives me negative 6x squared. 3x times 1 gives me just 3x. Negative 6 times negative 2x gives me a positive 12x. And negative 6 times 1 gives me a negative 6. So my final answer here is negative 6x squared. Let's put these together. 3 and 12 is 15, so plus 15x. And then minus 6 equals 0. Okay, and this was equal 0 way back here at the beginning. So that's where I got that from. This equals 0 here. Okay, so my A, B, and C. A is going to be negative 6. B is going to be 15. And C is going to be negative 6. Alright, let's plug those. Again, here I'm just rewriting so that I have the numbers readily available. A was negative 6, B was 15, C was also negative 6. Okay, and let's plug those in here. So x equals negative b would be negative 15, plus or minus the square root of b squared would be 15 squared, minus 4 times a times c, so that'd be 4 times, oops, negative 6 times negative 6, all over 2 times negative 6. So take a minute to copy that down and make sure you're really understanding why I'm putting each one of these numbers where I am. If you can't figure it out, look back at the formula and look back at what we laid out with our numbers. So as I continue to solve that, I would start by doing just what's underneath the radical. Okay, you can also do the 2 times negative 6 at the bottom. So I get negative 15 plus or minus the square root of, oh, let's see, that's going to be, oh, I might have to actually type that in. So 225. Okay, that comes out to be 81. How convenient. Over 2 times negative 6, which is negative 12. And then remember, we're now at the point where we have to use this plus or minus. And as soon as you use the plus or minus, you're going to split into 2 separate problems. So this is now negative 15 plus 9 over negative 12. And the 9 came from the square root of 81 here. And then negative 15 minus 9 over negative 12. Well, let's see, negative 15 plus 9 would be negative 6. And negative 6 over negative 12 is 1/2 or 0.5. Here, negative 15 minus 9 is negative 24. And negative 24 over negative 12 is equal to positive 2. So your final answers on this one are x could equal 0.5 or x could equal 2. Okay, every one of them is going to work exactly the same way. Lay out your a, b, and c, put it in your formula, and solve using this same method. So please make sure you're writing this down so you have a good example to look at later. One last example, and this one we want to do beginning to end. I didn't even lay out the steps for you. So first thing I need is I need this to be in standard form. It's not right now. I want to move the 3x over, but when I move it over here, I want to make sure I put it in the middle so that that standard form, the x squared and then the x and then the number, stays intact. So my final equation looks like this. 2x squared minus 3x plus 5 equals 0. Okay? And here's my A, here's my B, here's my C. So my formula starts with negative B. Well, my B is negative 3, so that means I'm going to make it a positive 3, plus or minus the square root of negative 3 squared minus 4 times A, which is 2, times C, which is 5, all over 2 times A, which is 2 times 2. Well, that's going to give me 3 plus or minus the square root of 9 minus 40. It's going to be negative 31 all over 4. Okay, do you see a problem here at all? See this right here? This can't be done. Okay, this is not possible. Can't take the square root of a negative number. So right here at this point where I'm saying that I need to take a square root of a negative number, for now, we're just marking these as no solution. There are what we call imaginary solutions, which we'll talk about right at the beginning of second semester. But for now, in a problem like that, I would like you to just mark that it's no solution after you reach this point. And I must see work up to this point shown. Okay, to show that you didn't just guess and say, hey, that's probably a no solution. Okay, so assignment for tonight, Lesson Master 6-7B, that will be due tomorrow along with your assignment from yesterday.